The dawn of the 1970s found American aircraft manufacturing at a pivotal moment. The roar of the Boeing 747, the queen of the skies, symbolized an era of unprecedented growth and optimism. This wasn't just an airplane, it was a flying hotel, a marvel of engineering that promised to shrink the world. Companies like Boeing, McDonnell Douglas, and Lockheed were at the forefront, pushing the boundaries of what was possible in commercial aviation. The 747's success, along with that of the DC-10 and L-1031 TriStar, cemented America's reputation as the global leader in aerospace. But beneath this gleaming surface of innovation, economic turbulence was brewing. The oil crisis of 1973 hit hard, skyrocketing fuel costs and forcing airlines to rethink their strategies. Suddenly, the very size that made these jumbo jets so impressive also made them incredibly expensive to operate. Manufacturers had to adapt, quickly shifting focus from sheer capacity to fuel efficiency. This wasn't just about selling more planes, it was about keeping an entire industry and thousands of skilled jobs flying amidst unforeseen headwinds. The factories, once humming with boundless ambition, now faced the daunting task of reinventing the future of flight, all while maintaining their edge against emerging international competition. This was a true test of American ingenuity and industrial might. As the commercial sector navigated choppy waters, the latter half of the 1970s saw a renewed focus on military aviation. The Cold War was far from over, driving significant investment in advanced combat aircraft. Iconic fighters like the F-15 Eagle and the F-16 Fighting Falcon emerged as epitomes of American air superiority. These were not just faster or more agile, they incorporated cutting-edge avionics and materials, transforming aerial warfare. Manufacturers like General Dynamics, McDonnell Douglas, and Northrop poured their engineering prowess into these projects, ensuring that the U.S. maintained a technological edge. But it wasn't just about raw power, it was also about efficiency and versatility, lessons learned from the commercial world. The demand for these sophisticated machines created a stable backbone for the industry, offsetting some of the slowdowns in commercial airliner orders. This era also marked a quiet but significant shift in manufacturing processes, with greater integration of computers in design and production, laying the groundwork for future advancements. The factories, often vast and secretive, became crucibles of high-tech manufacturing, employing legions of engineers, machinists, and assembly line workers, each playing a critical role in producing the nation's defense capabilities. This specialization wasn't just about building planes, it was about forging national security and technological leadership. The early 1980s witnessed a cautious but determined resurgence in commercial aircraft manufacturing. Airlines, having weathered the fuel crises, were now looking for more efficient, mid-sized aircraft that could open new routes and operate profitably. Boeing responded with the twin-engine 757 and 767, representing a new generation of fuel-efficient designs. These planes were not only economical, but also pioneers in digital cockpit technology, reducing crew workload and enhancing safety. McDonnell Douglas continued to refine its DC-9 series, evolving into the MD-80, a workhorse for many domestic carriers. However, this period also introduced a new dynamic: intensified global competition. European consortium Airbus began to make significant inroads into the market, challenging America's long-held dominance. This meant that U.S. manufacturers could no longer rely solely on their established reputation. They had to innovate faster, build smarter, and deliver more cost-effectively. The stakes were higher than ever, pushing companies to invest heavily in research and development, streamline production processes, and optimize supply chains. The factories hummed with renewed purpose, driven by the dual pressures of market demand and fierce competition, ensuring that every rivet and every weld contributed to keeping America at the pinnacle of aerospace engineering. By the mid-1980s, American aircraft manufacturing was undergoing a quiet revolution driven by innovation and integration. The advent of powerful computers fundamentally changed how aircraft were designed and built. Computer-aided design, or CAD, moved from novelty to necessity, allowing engineers to simulate complex aerodynamics and structural loads with unprecedented precision, cutting development time and costs. Concurrently, the industry embraced new materials. Composites, lighter and stronger than traditional aluminum, began to be incorporated into key airframe components, promising greater fuel efficiency and longer service life. This wasn't just about incremental improvements, it was about a paradigm shift in materials science and engineering. Companies like Boeing and Lockheed invested heavily in advanced manufacturing techniques, pushing the boundaries of automation and precision. The factories themselves evolved, becoming more sophisticated, integrating robotics where possible, and demanding new skill sets from their workforce. This era set the stage for the next generation of aircraft, where digital design and advanced materials would become the norm, solidifying America's leadership in aerospace innovation, even as the global landscape continued to evolve. As the 1990s approached, the American aircraft manufacturing industry stood on the cusp of another new era, built on the formidable legacy of the preceding 2 decades. The lessons learned from the challenges of the 70s, the military innovations of the early 80s, and the commercial resurgence and technological leaps of the late 80s all converged. Companies had diversified, innovated, and adapted, ensuring their competitive edge. The factories, once symbols of sheer industrial might, had transformed into sophisticated hubs of high-tech engineering and precision manufacturing. The people, the engineers, the designers, the machinists, the assembly workers, had honed their skills, passing down invaluable knowledge through generations. This was a testament to American ingenuity and resilience. While the global market would continue to bring new competitors and challenges, the foundation laid between 1970 and 1990 ensured that the U.S. would remain a dominant force in the skies, continually pushing the envelope of flight, from the mighty jumbo jets to the sleekest fighters, always looking towards the horizon of what was next. The roar of these titans of the sky would continue to echo, carrying with it the legacy of American innovation.